Hello. Today I wanted to show you an electricity monitor that I built. I wanted a way to measure how much electricity was being consumed in the house, not just as a cost-saving measure, but also out of curiosity to see the trends and what sort of data I could get out of one of these. I could have bought a smart meter or opted in for one of those ones some energy companies are trying to introduce, but this way was far more interesting for me, and I also feel far more in control of the data leaving my house. Not to add that since this is a DIY project, I could monitor and manipulate any data I wanted from it in any way I wanted. I built this before I started recording videos, so I didn't think to capture the process of me building it. It took me a long time anyway, so instead I'll do my best to walk you through all of the bits involved. In this video I'll show you an overview of the meter, and if the interest is there maybe I'll release another talking through the circuit design in more detail. Before I do though, let me show you the working meter in action. The meter itself measures mains AC voltage and current. It also grabs its own power from the voltage line as well. For the voltage line, I'm using this cable. This will just plug straight into the main socket, and I won't be using the earth line as there's no earth on this yet. If there's a metal housing or something, it would definitely be connected to that, but for the sake of this example, I just need the live and neutral. All I need to do with this is carefully plug this into the voltage terminal. With the voltage safely connected, it's unpowered at the moment, and the earth cable safely out of the way, the next thing to do is connect a current clamp meter. This is a transformer that clamps around a single conductor. It has a jack on the other end which outputs a current proportional to the current that is inducing a magnetic field in this coil. There's just a ferrite ring in there with a transformer. This particular model is a YHDC SCT013. It can measure up to 100 amps, and at that 100 amp current, it will output on this jack a 50 milliamp current. So it's as simple as connecting the jack to the socket I've designed for up here. The next thing to do is fire it up and see what happens. So we turn it on, it takes a moment to fire up. If we zoom in, we can see the meter has started monitoring. I need to be careful here, as while normally this would be in an enclosure safely tucked away, these terminals on the end here and that fuse are carrying mains voltage. Other than that, you can see the voltage is being measured. Here in the UK, it's 250 volts AC that's being measured. There's a 0.88, 0.55 amps being measured, even though there's nothing connected to the clamp just yet. That's just noise. It's not an issue at the moment because I'm not doing this for super accurate readings. And also the currents that I will be measuring will be for the whole house, so I'm not worried about the 350 milliamps here. The watts and the kilowatt hour usage are low enough for me to assume nothing is connected here. Two things you might notice here are where it got the time from and the send success message. There are also various error messages that can appear. What this is about is back here there's an ESP8266 Wi-Fi module. As well as the data being displayed on the screen, the module is sending the data to a server through the Wi-Fi module. The server is replying with the current time and also saving the data to a database. From the database, I can access the information from a web browser on my PC, tablet, phone, or anywhere else I wanted to. Let's zoom out and try an example with an iron. So I have an iron. This one's rated for 1200 to 1300 watts. How I'm going to be measuring this one is obviously the mains voltage is the same around the house, and I've made this very bad hack of an extension cord. It's a plug on one end and a standard socket on the other end, and this is a very badly wired extension cord. The reason I'm doing it this way is for a current clamp to work, it can't clamp around a twin core mains cable because of the two conductors inside the cable. In these conductors, The current is going one way in one and the other way in the second. The magnetic fields would cancel each other out, so the current clamp wouldn't read anything. So I need to clamp this around just one of them. This isn't the final use case where I'm going to connect it, but for the sake of this video, it should be enough. I'm going to clamp this current clamp around the live wire, taking note there are arrows on the edge of the clamp, so this wanted to be facing towards the socket. Now, in theory, anything I plug into this socket will be picked up by the energy meter, so let's try that out. With everything connected, let's power it up. I want you to keep an eye on the current and power units on the screen. I'm also including the web interface over there, so you can see the information update live. When I say live, this sends a reading every 5 seconds, and the web interface updates the charts every 5 seconds, I believe. So let's take a look. Let's turn this on. The current immediately jumped to 5.25 amps, and we are at the rated power of 1.3 kilowatts. You can see the spike on the web interface, and that will continue to monitor. You can see how relatively stable that is. The voltage fluctuates a little bit, but this is the nature of mains voltage. The current is what's keeping relatively stable though. If we scroll up and down the page, we can see the summary at the top. Currently we're drawing 1.3 kilowatts, which is in line with what's on the meter screen and on the iron. I've added a bit where I can measure the current cost per hour. So if I was to continually use this amount of power for 1 hour, this is how much it would cost me. This is an accumulation of the entire day's kilowatt hour units, and this is just a multiplier of how much power was used throughout the day so far against what the tariff is. Scrolling down, we've got the voltage, current, and power used. There's more information down here. We've got a daily chart and a monthly chart which displays historical data. So that's the gist of how it works. You've got the voltage coming in, which doubles as a voltage monitor, as well as powering the device itself. Then you have a current clamp. I intend to put this on the mains line coming into the house, and that way I can see the current consumption throughout the entire house. For the sake of keeping this video short, I'll end it here. In the next video, I'll show you around the board in more detail, and maybe in the future I'll go into the circuit design aspect of it. Thanks for watching. Bye!